How to talk about a graph. For many poster presentations and other academic presentations, graphs are critical for representing your data, findings, results, and conclusions. But although your graphs are very familiar to you, they can be totally new to your audience, and helping your audience understand is the whole point of your presentation. That's why how to talk about a graph for your research matters. So here comes my super clear explanation on how to talk about graphs at an academic conference. First, I'll present a simple framework that you can follow. Then I'll apply that framework to two real examples of graphs so you can see how it works. A framework for talking about graphs. A framework that provides a strong explanation will include a graph introduction, talk about the title, x-axis, y-axis, the key, also called a legend, and the style of the graph, and what each point, line, and bar means to help the audience orientate. An example data point explained. Pick a typical data point and explain what it means. Interesting trends. What patterns are forming? What connections can you make between data? Outlying data. What data seems to be quite different or far away from the average? Surprising data. What data is not what you would have expected? Conclusions. What are the obvious conclusions? What are the surprising conclusions? Let's see how these 6 points can be applied in real examples. Example graph 1. A weak explanation, then a strong explanation. For this example graph, we can see the relationship between fish weight and fish length. Here is a weak explanation of this graph. This graph proves that bigger fish weigh more. This explanation is weak because it doesn't mention any of our 6 key points. A graph introduction, an example data point, interesting trends, outlying data, surprising data, or conclusions. So here is a strong explanation of this graph. This scatter plot graph is on the relationship between fish weight and fish length. On the y-axis, we have the weight of the fish in grams, and on the x-axis, we have the length of the fish in inches. Each of the 20 data points on the graph represents a fish. For example, this point here represents a fish that is 0.79 inches in length and 1.5 grams in weight. This point here seems to be outlying, but we calculated that it fits within our standard deviation. As we can see, there is a linear relationship between the fish weight and the fish length. This strong explanation starts with an introduction to the table's title and headings. This strong explanation takes the pressure off the audience to interpret the many lines of data by walking them through the main categories and interpretation. This strong explanation mentions 5 main points: a graph introduction, an example data point explained, interesting trends, outlying data, and conclusions. This graph doesn't have any surprising data, so none were mentioned. If you have any questions, you can leave them in the comments below. I will read them and reply. Additionally, if you have enjoyed this free content, please hit like and subscribe. Thanks. Now on to example graph 2 with a weak explanation, then a strong explanation. For this second example graph, we can see how body weight impacts bicycle riders' calorie burn rate. Here's a weak explanation of this graph. Obviously, heavy people burn a lot of calories, and they burn more calories when they ride faster. This example is weak because we don't want to say obviously. It's best to assume that nothing about your data is obvious to your audience. Additionally, heavy, a lot, more, and faster are all vague words. Vague means unclear or unspecific. This is a weak explanation because it doesn't mention any of our 6 key points: a graph introduction, an example data point explained, interesting trends, outlying data, surprising data, or conclusions. So here is a strong explanation of this graph. This graph depicts cyclists' caloric expenditures at different weights and speeds. On the y-axis, we have calories per hour, and on the x-axis, we have average speed in miles per hour. Each curve shows the calories burnt per hour for a given speed. There are different curves based on the rider's weight. Each color represents a different rider's weight in pounds. We can see that the relationship between calories burnt and the speed is not linear. It appears exponential for all rider weights. Also, at lower speeds, riders burn between 200 and 350 calories per hour depending on their weight. The curves are close together. However, when biking at faster speeds of 25 miles an hour, we can see a larger difference of 700 calories per hour between the lightest rider and the heaviest rider. That is, heavier riders burn increasing amounts of calories per hour as their speed increases. This strong explanation mentions 5 main points: a graph introduction, an example data point explained, interesting trends, surprising data, and conclusions. There is again no outlying data in this graph, so none were mentioned. Now you know the framework for talking about your graph at an academic conference. To recap, here are the 6 main points you should cover: a graph introduction, an example data point explained, interesting trends, outlying data, surprising data, and conclusions. If you want to get more videos on academic writing, publishing, and presenting, then subscribe to the University English Hub. Thanks, and I'll see you in another video.